Hello friends, today I am discussing a problem from this diverse list DP series of minimum path sum in grid. So this is the lead code problem minimum path sum. So we have given m into n grid and filled with the non-negative integers and so find a path from top left to bottom right which minimize the sum of all numbers along its path. So yeah, we are doing this problem using memoization. So uh, let's understand. Let's take this example and we will discuss how we are going to do. Yeah. So we have given a grid. Yeah. So, so we have given a grid of one, three, one, 1, 5, 1, 4, 2, 1. So what we have to do, we have this is the start point and this is the end point. So we have to come from the start to end and we have to minimize the path sum. So let's see this is 1, 3, 1, 1 and 1. So if we choose this path, uh, we can come to this point using 3, 4, 5, 6 and 7. Using 7 path sum. And let's say if you choose other path, like if you choose this path, we can come to this point using 1. It's not 5 easy as let's do this first. This is 1 and this is 1. Yeah. So if you choose this path, then the path sum will be 6, 7, 8, 9. Similarly, all other paths. So you can move to the right or the down, not to the diagonally. So if you choose this path like this, so using this path, we will reach to in the end point. The path sum will be 4, 9, 10, 11. Similarly, we can calculate which is the minimum, and we have to return the minimum path sum. So how you can do using dynamic programming and using memoization method. Let's see how we are going to do this. So we have something like this. Something like this. So we have to minimize the path sum. So there is a lot of paths. So how we can minimize this? So this is the final point. This is the final point. So uh, in recursive method, there's two ways to reach this point from here. and from here. So this final point, ask this point, hey, how many ways that a man reached to you in the minimum path sum, and the path sum will be minimum. So this will return some value, let's say A. And similarly, this 6, this final point, ask this, hey, how many ways that a man reached to you in the minimum path sum? This also returns some value, let's say B. Then 6, similarly, okay, so if the value is B and this return value is A, then the minimum path sum till this point will be 6 plus minimum of AB, minimum of A and B. So this is the recursive method. So similarly, this 5 ask this grid, hey, how many ways? Hey, what will be the minimum path that minimum path sum that a man can reach to you? And similarly, path 5 ask grid, this grid that hey, how what is the minimum path sum that a man reach to you? And this also returns some value. This 8 also returns some value to 5. Then 5 will decide, okay, so which is the minimum, and we will add 5 to this 5 to that, and return to 6. So similarly we can do for all. So so the main thing we have to notice is we have to do this in our recursive method. So yeah, this is not so difficult question. So yeah, let's understand the coding part. So this is my method. This is my solution. So this is the function which is given to us. So we have given a grid in which some non-negative integers. So yeah, so I'm filling the -1 to the dp. So here, this is the function which we are calling. So I'm passing the index, which is m minus 1 and n minus 1 of the grid, and we're iterating from the last. We're iterating from the last. So I'm taking this index, last index, and this is some base case. So if m is negative or n is negative, then we have to return int max. So because we are minimizing this value, so when return int max, then this will take the minimum value. So again, if m is 0 and n is 0, then we have to return the grid mn. So the value of the value in that grid. So and if there is no -1, so if we pre-calculated the value, then we have to return that value. And here what we are doing, what we discussed, that grid m plus n plus minimum of this grid, and this grid. So which whatever is minimum, we add we have to add that value to our grid value, and we will store in our index, and finally return the value of the last cell, bottom right cell. So yeah, that's it. And yeah, so again, the time complexity is uh, which is order of mn. Yeah, time complexity is order of mn because we have given a grid and we are iterating for all the elements. So let's see. So the time complexity is the order of mn, and space complexity of order of mn. So mn, yeah. So out of mn plus out of a static space will be coming from the recursive method. Yeah, that's it.